In this video, we're going to be looking at square roots. We usually use one of the two symbols that you see before you to indicate a square root. Usually it's the one on the left, but sometimes we will see the one used on the right where we see the small 2 sitting on the shelf. That 2 that you see there is called the index. The symbol itself is called the radical. And the value underneath the radical is called the radicand. Please note that the square root of a radicand is the number we squared to get that radicand. So for example, with our square root of 9, we know that the square root of 9 is 3. And why is this? Well, it's because if we went back and we took that solution of 3 and squared it, that would take us back to the value of 9. Lastly, if we wanted to simplify a square root and provide its exact answer, in other words, not necessarily default to using a calculator every single time, prime factorization is going to be our friend, and these will be demonstrated in the practice problems to follow. Let's take a look at some examples. So the first one we have, you've probably seen quite often and already know the answer to, but I'm going to show you how to use prime factorization in order to help you evaluate a square root. In this case, we have the square root of 25. So again, if we want to write in that index so that we can see it, I'm going to go ahead and do that now. This basically is telling me in order for any value to escape the square root, it needs to have an identical twin in order to get out. So in this case, if we look at 25 and we want to think what two numbers would multiply to give me 25, that would be 5 times 5. Now, I cannot go any further. The only way to break down 5, in other words, the only way to answer the question what two numbers can multiply together to give me 5 would be 1 and 5. And that really doesn't add anything to the conversation. So 5 is a prime number. Since it's a prime number, I'm going to go ahead and circle it to indicate I cannot go any further. I've found all of my prime factors. The other thing to note with regards to prime factorization, we can almost treat this as the genetic code of a number. These are the basic numbers that cannot be broken down any further. So what I also want to note is, again, my index is a 2, so that's saying I need a pair of identical numbers in order to escape out from underneath the radical. Well, it just so happens that in this case, I do have a pair. It's a pair of 5s. When I write my answer, though, I want to note that my answer is just 5. The 5 that I've just written represents that one couple that escaped. Now let's try our hand at the square root of 243. Again, if we're using prime factorization, we want to think first what two numbers can multiply together to give me 243. Just as one example, we could note that 243 will break down into 3 times 81. Really quickly, you might be asking, how did I know that? There's this little trick where if you add up all the digits of the radicand, so in this case 2 plus 4 plus 3, I get the value 9. Because 9 is a result of is one of the result of your 3 times tables, that tells me this number is divisible by 3. Go ahead and tell your friends and share this at all holiday parties. So from here, I'm going to note 3 is a prime number. I cannot break it down further, but I can break down 81. That, for example, would be 9 times 9, and then 9 can be broken down into 3 times 3. For good measure, I am going to run an x through 81 and 9. I don't want to go back to those numbers because I already broke them down. Notice that 81 is the same thing as 3 times 3 times 3 times 3. So by running x's through them, I'm eliminating that, I guess, slight urge to use them again. So again, we are working with an index of 2 because we're working with a square root. So I'm going to look for pairs of identical numbers. So I see I have one pair here, and I have a second pair here. So the numbers that escape on the outside will be one group of 3, and then a second group of 3. The next thing to note here is that I still have 1 3 left over. He does not have a partner. So that 3 has to remain underneath the radical. The last thing to note, if you are able to pull out more than one number, we would multiply those two numbers on the outside. Very similarly, if we had multiple values that had to go back underneath the radical, we would multiply those back together. So my answer here would be 9 times the square root of 3. Lastly, let's take a look at the square root of 15. Again, with prime factorization in mind, what two numbers would multiply to give me 15? That would be 3 times 5. Again, note 3 and 5, I cannot break down any further. These are prime numbers, so I have to stop here. And in order for values to escape, they need to have an identical partner or an identical twin with them. 3 and 5 are not the same, so because they are both different, neither one of them is escaping. We are going to multiply them together and put them back underneath the radical. So in this case, my answer doesn't change. I cannot simplify the square root of 15 any further. Okay, now it's your turn. You have the square root of 81, the square root of 41, and the square root of 125. Go ahead and take some time to simplify these square roots, if possible. When you are ready, go ahead and press play, and we will review these problems together. So for our first question, the square root of 81, you may have already known this one by heart, but I did include the prime factorization work here just in case you were interested. One way that we could break down 81 would be 9 times 9, and then we could break each of those 9s into 3 times 3. Keep in mind that if you went a different route, you still would have ended up with 3 times 3 times 3 times 3. Here we have two pairs of 3s that will escape. So we would write that as 3 times 3, and then we would multiply those two numbers that escaped, so we would get a result of 9. Likewise, if we look at the square root of 41, there's really not much that we can do here, because 41 will only break down into 41 times 1. It's a prime number to begin with, so because we don't have any identical pairs, no one escapes. Everything has to go back underneath the radical. If the problem that you are working on says that it's okay to provide a decimal approximation, this is where you could default to using your calculator and to type in the square root of 41 to get an answer, to get a decimal answer, which you would most likely need to round to a specified decimal place. Lastly, let's take a look at the square root of 125. Looking at that, since it ends in 5, if I didn't know how to begin to break this down, since it does end in a 5, that tells me that it is divisible by 5. So this is why I wrote down 25 times 5, and then again 25 will break into 5 times 5. I did run an x through the 25, so I wasn't tempted to go back and use it later, because again, I already broke it down into 5 times 5, so I don't want to go back. I do see that I have a matching pair of 5s that will escape, and then I have one 5 that does not have a partner, so it must go back underneath the radical.